try to create a schematic, to design a schematic as fast as possible.
No problem. Challenge accepted. So, in EPLAN, you have an environment that helps you create schematics efficiently and quickly. At a very minimum, we provide you with symbol libraries where you can access all of their various different symbols associated to electrical design and help you access them quickly. Well, I thought you were going to give me a challenge, so I did a little bit of preparation up front. So I kind of collected the symbols that I'm going to use for this particular example in a collection of tags. So you can add tags to your symbols and group them together to help them access them quicker. So let's start with a power rail, right? I'm just going to drag my power rail, and right there, if I hit X and Y, I can place them right exactly where I need them, and I'm already started. Now let's create a motor control, right? Just a simple motor control application. So I'm just going to take my motor, drop it in here, and the first thing you notice is the motor is automatically tagged and labeled. And what I'm doing here is I'm not just placing graphics, I'm really placing data. So all of this data we can use and we can leverage to enhance our productivity at the end of the day. Then I'm going to connect this motor to my power rail, so just simply here drag my T connections. Of course, I need to make sure that the motor is grounded, so I'm going to bring the ground back to the control cabinet, just drop it in here. And now what's next? I need to make sure the motor doesn't blow up. So I'm just going to protect the motor with a protection device, and I just go to here, you can see drag it across, and this is the fun part of the auto connecting lines. Seems such a mundane task that we just use every single day, but it really is powerful when you start putting components together. Here I've got a contactor, and I'm just going to drag it across again and drop the contactor. And now I'm going from the cabinet, we talked about terminals, out to the field, so I'm going to drag a terminal strip across here. And of course, we need a cable, so I'm simply going to add a cable onto my drawing. And here we go. My first part of the design is completed. So here's a very simple motor starter circuit, but as you can see, easy to just drop the symbols and place them. And if you need two of them, well, just simply highlight it. I can just duplicate it, and then I can move it across. And one thing that you'll notice is everything gets tagged automatically. Even the terminal strip, if you look at the terminal strip, it goes sequentially through. It labels the cables. Everything's done. I really don't have to do much.
Cool.
So did that pass the first challenge?
Yeah.
Okay.
It was fast. It was fast.
It was pretty cool.
I think it perfectly shows, as you said, that this is not only graphic, but it's data behind, and therefore the system can support in that numbering function or in breaking up the auto-connecting lines, etc., and all that stuff, so that you get rid of this repetitive tasks and this mundane work.
Absolutely.
Yeah? So, okay. But I know, Sean, that you have more power to even be faster, and maybe let's just call it challenge number 2, be faster, and maybe this has something to do with standardization and templates?
Okay, I will try. So let's just open up a new page. I'm just going to call this page standardization, and let's see what we can do better this time. Okay. So let's start with a power rail. No matter what, I need my power to come into my page. Now, instead of placing symbols, I'm going to place a macro. What's a macro? It's like a template of a circuit, and that way you can easily drop that circuit onto the drawing. So here we've got a motor starter module. So again, I'm going to position it in its default position. And now what I'm going to do is I'm going to hit the tab key, and look what's going to happen. It's going to give me different variations of that specific circuit. So I have everything that I need to design a control system right at the tip of my fingers. And all I need to do is simply navigate through those different variations and access them as needed. So let's pick these variations, for example. I'm just going to drop it in. And now what comes up? Now it's even going to ask me, what size motor would you like? Because what happens when I change the size of the motor? I need a different power, I need a different protection device. The contactor size might change. The contactor cross-section or the conductor cross-section might change. So a lot of different changes are happening just by changing this value. So here, let's just select a 5.5 kilowatt motor for this application. And as you can see, automatically it sized the fuse, it sized my protection device, it sized my contactors, and all of the cross-sections at the same time. So I hope I was even faster than before by just dropping it in, but also adding all of the engineering data behind it automatically.
Cool. Definitely faster, but now back to reality.
What?
You know that, as we already talked about this calculation topic, there's maybe always the risk that the mechanical guys call you, and you now choose the 5.5 kilowatt motor, and they say, hey, we have to move bigger packages, maybe on a conveyor belt, we have to switch to 11 kilowatts, for example.
So you're changing the length of the cable, and now you're changing the size of the motor as well? Oh,
exactly.
come on.
So,
Well, it's not a problem in EPLAN either, because you simply select this placeholder technology, and this placeholder technology carries all of those values that you need to switch. So by simply going from a 5.5 kilowatt, what did you say, 11? 11?
Yeah.
So let's select an 11 kilowatt motor. You can see that the part numbers automatically get adjusted, and I really don't have a lot of work to do. It adapted all of my protection devices, it adapted my cross sections, and everything's done. So that was really not a lot of work.
Cool.
I need a better challenge than that.
Yeah, yeah. And now I'm with you. That is really fast, and it's flexible as well. So because that means, again, when we think about libraries, I can put all this in a library, and this is somehow my know-how tank, huh? Right?
Exactly. And that's part of the standardization process.
Yeah.
You build up your standardized blocks that you're going to use, and then you put them in a library, and then you just pull from that library to build your entire package efficiently and quickly.
Cool, really cool. And that underlines really the story, that it can be done step by step, and that it's really an approach to go further in that standardization topic with every project.
Absolutely.
Yeah? Cool. But no, Sean. Okay, now it's the final level. Let's do the final level, and really let's take the give you the possibility to show that you can do it even faster.
I can.
Okay.
So the other aspect is now we're taking the standardization to the next level. Now, as you can see, I took this motor and I placed it on a page. I would have to create another page, place another motor. Took another page, place another motor. How about automating all of that? You like automation, Thomas?
Of course.
So let's go ahead and automate this process. And now we're going to talk about automated engineering. And I think they mentioned, just to repeat, the EFA.
Yeah.
What is it? The EPLAN form for automation?
For automated engineering.
Well, automated engineering. That'll be again in September. So if you have some time, go and visit it. It's really cool. But this is just the tip of the iceberg that I'm going to show you here, and how to automate it even further. So now let's go into the cloud. So I'm going to access in the cloud a tool which is free. It's called eBuild Free. And what is eBuild Free? eBuild is a collection of configurators that allow you to configure a project, click on a button, and generate schematics. So you really don't spend any time designing anymore. You really spend time configuring your project and then generating the results. So let's go ahead, and I've got a little example here, which is my sample macro project. I'm going to drop the pages in my engineering challenge project, and now I'm going to add some little bit of configuration, not too much. So here we're going to select a project with some variants. I need a measuring transducer. I need some lighting for my first enclosure. How many receptacles do we need? 1 or 2?
Take 2.
Just let's take 2 for the first one. Do we need light for the second enclosure?
Better.
Okay, and then how many sockets for that one?
Just your choice.
I'll take one. One for that, I think, is optional. E-stop, I don't think we need it in this one, and we're just going to control the motors with a reverse contactor. So there we have it. I just configured my project, and now let's see what happens. So before, we were able to go and take some coffee, but I think, did you start the timer?
Yes, I did.
And how long do you think it's going to take?
It's now about 10 seconds.
10 seconds?
Yeah.
Okay, so we probably have a lot more. What? Done already?
It's done. Cool. Cool.
How many seconds? 13, right?
13, yeah.
13 seconds. So within 13 seconds, what did we do? We generated an entire project with all of the documentation needed. And this project, if we look at the data, it's 65, I think, 63 pages were created. So there you have it. Within 13 seconds, I was able to create an entire project with 64 pages of documentation right there and then, automatically from a configurator. But again, you need to be standardized for that. So the step process is using an efficient tool like EPLAN, creating your standardized circuits, plugging all of that into a generator, and then leveraging that information to generate all of your documentation. So now I got nothing more to do.
Yeah. That was awesome fast, Sean. Thank you very much for this very impressive presentation and for the stepwise approach that we start with symbols, already have the powerful functions in the software, and then really grow and talk about standardization and automation. And maybe to do it, or maybe to just point it out again, if you are interested in that topic, you can go to the EPLAN cloud environment at eplan.com and try out eBuild Free. Just to get in touch with that option, of course, you need the latest version of EPLAN to do so. And the libraries are predefined libraries. So we put together some examples Sean, you use that example that is there available, and just try it out, get an idea, what are the possibilities when you automate your design process, and then of course when you want to step in to create your individual libraries, then it's to make the step to e-build or Cogeneer to really step into that automated engineering process and be as fast as we just experienced.
Absolutely.
So thank you again.
My pleasure. So, the other aspect is now we're taking the standardization to the next level. Now, as you can see, I took this motor and I placed it on a page. I would have to create another page, place another motor. Took another page, place another motor. How about automating all of that? You like automation, Thomas?
Of course.